Precision length begins with a surface that can be trusted. A gauge block carries no scale and has no moving parts. Its value is the calibrated distance between two lapped faces. Every later comparison depends on how faithfully those faces preserve that reference. A single block represents one known length, while a rung stack creates thousands of possible combinations. That simple modular idea supports instrument checks, computer setups, and angular fixtures. The challenge is keeping every contact face clean, stable, and repeatable through years of handling. For the zirconia grade described here, Vickers hardness is stated at 1200 to 1450 HV1. That hardness helps the lapped faces resist fine scratching and local wear during repeated handling and wringing. Preserving the face geometry is essential because surface condition directly affects contact and stack length. Hardness alone is not enough for a reference that is picked up, cleaned, and stacked repeatedly. The stated fracture toughness range is 6 to 8 megapascal square root meters. Zirconia transformation toughening helps slow crack growth, reducing the tendency for small edge damage to propagate under normal careful handling. Zirconia does not rust and is non-magnetic, so storage and measurement are not complicated by corrosion products or magnetic attraction. Its stated expansion coefficient is about 1 × 10 to the -5 per degree Celsius. Temperature still matters, but the material remains predictable when the reference and workpiece are allowed to equilibrate. Wringing brings two clean, flat faces into intimate contact. A very thin residual film, surface tension, and local molecular forces allow the blocks to adhere without a mechanical clamp. Dust, burrs, or poor contact interrupt that interface and can create an incorrect stack height. The nominal lengths in a stack are added, but the measurement is not arithmetic alone. Every additional interface introduces another pair of surfaces and another wringing condition to control. Efficient setups therefore use a practical combination with clean faces, good adhesion, and no unnecessary handling steps. Dimensional metrology uses 20 degrees Celsius as the standard reference temperature. Gauge block calibration reports length at that condition, and temperature corrections depend on block length and expansion coefficient. Even a stable ceramic reference needs time to reach equilibrium before a high-accuracy comparison begins. ISO 3650 covers rectangular gauge blocks with nominal lengths from 0.5 to 1000 mm and defines calibration grade K together with grades 0, 1, and 2. Working sets concentrate many fine increments in shorter lengths, allowing target dimensions to be assembled without carrying a separate block for every possible value. Set design follows the measurement task. Metric or inch units, single replacement blocks, rectangular or square forms, fine increment bands, and selected accuracy grades can be combined around the required workflow. Customization must preserve the same priorities: calibrated length, parallel faces, flatness, surface quality, and traceability. In Sine-Bar angle calibration, the required stack height is calculated from h equals L multiplied by the sine of the target angle. The gauge block stack raises one roller by that exact linear distance. A known length is therefore converted into a controlled angle without relying on an engraved angular scale. The stack must remain coherent beneath the Sine-Bar while the setup is positioned and checked. Hard, where stable zirconia faces support repeated contact, and good wringing minimizes uncertain gaps between blocks. Cleanliness, face condition, and temperature equilibrium determine whether the calculated height becomes a trustworthy physical reference. After the stack is installed, a comparator or indicator verifies the work surface against the reference plane. Repeatability depends on the Sine-Bar geometry, the stack height, and disciplined handling of every face. A precision angle is not created by the fixture alone. It begins in the quiet certainty of each micrometry inside the stack.